We're going to work on parallel lines, and hopefully we'll work up to the perpendicular lines also, but we'll start with just parallel so you can see this idea. Once we get the equation for the parallel line, a good idea so we can practice graphing would be to graph the line that was given and the line that we find that's supposed to be parallel to it, and then we can visually look at our graph and make sure that it's correct. I probably will not graph on here, but that's a good idea for you to be able to do after you've finished your work and check your answers. So we're going to start with parallel lines. So the first thing about parallel lines is you have to remember the definition that these lines are in the same plane, but they do not intersect. So they're always the same distance apart. And in order to keep them the same distance apart, they have to have the same slope. So if we're looking at equations, we could tell if they're parallel if we know the slopes of the lines. So if the slopes are exactly the same, then the lines are parallel. So we're going to use that information, and what we're going to do is write the equation in slope-intercept form of the line that passes through the point -3, 5. And then we have to realize that it's going to be parallel to the equation that's given, y equals 2x minus 4. Now, the line that we're parallel to over here, the only information you need from this line is you need the slope. Okay, the slope of this line, this is in slope-intercept form, so the slope of this line is in front of x. The slope of this line is 2. Since our line that we're going to write the equation for is parallel, the slope we want to work with is 2. So we're going to work with the point -3, 5. And we're also going to use a slope of 2 since we're parallel to that equation. I don't want anything else from this line, so I want to cross it out so I don't accidentally use it. Now, I'm going to do the same process I did before. Work with y equals mx plus b. I'm going to fill in the x and the y from the ordered pair, and then I'm going to use the slope that I borrowed from the other equation that was given. So the y is 5. The slope is 2, and the x is -3. And again, just like we were doing before, multiply those two together. And since this is -6, add 6. So we'll have 11 equals b. So the equation of the line we're looking for, y equals 2x, because we want to use the same slope, and then our b was 11. Notice on the first equation it was y equals 2x minus 4. This one is y equals 2x plus 11. The only thing different is the number out here. Everything else looks the same. So let's try this again. This time the point is 4, -1. We're parallel to the equation y equals 1/4 x plus 7. So the slope here is the 1/4. Since we're parallel, we want to use the same slope for our line. So we're going to use this point, and we're going to use the slope of 1/4. So we're going to fill in our y equals mx plus b. And remember, good idea to cross this out. You don't want anything else from that line. The y is -1, the m is 1/4, and the x is 4. Now, 1/4 times 4, that's can be said 1/4 of 4. So 1/4 times 4, or you can think of that as 4 divided by 4, you'll get 1. When you subtract 1, because you want to get rid of the positive 1 here, on the left, -1 minus 1 will be -2. This, of course, will cancel, and you'll have b on this side. So our slope is 1/4, our intercept, or our b, is -2. So our equation will be y equals 1/4 x minus 2. And this would be our final answer. Let's talk about perpendicular lines. Perpendicular lines are very special lines when they go across. You may remember the word from pre-algebra. Perpendicular lines, they will intersect lines, and they will form right angles when they do this. So they'll form those 90-degree angles. In order to be able to get this situation to occur, you have to have opposite reciprocal slopes. And I also realize I can't spell reciprocal. I have two I's and it's just one. So you can fix that as you're writing. Opposite reciprocal slopes have a product of -1. So let me just talk about just if we had just the slopes to look at. If I started with a slope of 2/3, then the line that's perpendicular would have to have a slope of -3/2. So you have to change the sign and flip it over. So let's try that again. If we have a slope of -4, then we have to change the sign to positive. And when you flip 4 over, remember 4 is over 1 right now, it becomes 1/4. So they have opposite signs and they're reciprocals. Now, to see this part here about the product, if you're not sure, you can always check their products. For instance, 2/3 times -3/2, if you just multiply straight across the top, -6/6, which reduces to -1. The same with your -4/1 times your 1/4. You'd have -4/4, which would also be -1. So if you're not sure if they're opposite reciprocals, multiply them together on a calculator even and see that the product is indeed -1, and that will fix that situation and let you know if you have opposite reciprocals. All right, so what we're going to do now, we have to be a little more careful as we're working. We have to realize we're looking for a perpendicular situation here. Maybe if I could spell that word, it would help. It should be LAR at the end. So our line goes through -4, 6, and we're perpendicular to 2x plus 3y equals 12. So what we're going to do first is we have to find the slope of this line. So we're going to get the y by itself. This is something we practiced a few days ago. Subtract the 2x over. So 3y will equal -2x plus 12. Divide everything by 3. Y will equal -2/3 x plus 4. So the only thing I want from this situation is I want the slope. The slope here is -2/3. My line is perpendicular. So what I want to do is use a slope that has the opposite sign. So my slope will be positive. And then the reciprocal of 2/3 is 3/2. So I want to change the sign and flip it over. From here, I go back to the same work I've been doing. I don't want anything else from this equation. So I want to use y equals mx plus b. I want to use this ordered pair that was given. Change the y to 6. Change the m to the 3/2. Change the x to -4. And you can put that over 1 if fractions are easier that way for you. And plus b. So 6 equals, this would be -12/2. Which is -6. Remember, you could have canceled and reduced there before you multiplied. Then you'll add 6 to both sides, and you'll find 12 is equal to b. Now that you have b and you have m up here, write your equation. So y equals 3/2 x plus 12. And there's our equation of a line that's perpendicular to the one that was given. And we're of course going to try this again. All right, same spelling error I have here, so that's what copy paste does to you. So correct this. This should be LAR if you're writing this down or looking at it. Find the slope of this line. So here y is not by itself, so you'll have to just divide everything by 3. So y will equal 2/3 x minus 1/3. So your slope here is your 2/3. So the slope we want to use, the opposite sign would be negative, and then the reciprocal of 2/3 would be 3/2. So we're going to work with y equals mx plus b. We're going to work with the slope that we decided on, and we're going to work with the ordered pair, the x and y we were given. Nothing else from the equation over here. Fill in the y is 7, the m is -3/2, the x is 4, or you can say 4/1 plus b. So 7 equals This time I'm going to take the 2 and cancel into the 4 and make that 2. And of course this one becomes 1. So I don't have to worry about the denominator there. Negative 3 times 2 is negative 6. Then I'm going to add 6 to both sides and get 13 is equal to B. So here's B and here's M. We're ready to write the equation. Y equals negative 3 over 2x plus 13. And there's the equation that's perpendicular to the first one that was given to us. All right, the last little thing to kind of tie the parallel and perpendicular idea together, sometimes I'm going to give you equations and I want you to be able to tell me, are they parallel, are they perpendicular, or maybe they don't fit either of those situations. So what we're going to do is we're going to state the slope for each one. Then we're going to look at the slope and decide if they're the same. We're going to use the word parallel for the equations. If they're opposite signs and reciprocals, then we're going to say perpendicular. If they don't fit those two cases right now, we're going to say neither or neither. Now, this first equation is pretty nice. It's already in slope-intercept form. So the slope is negative 2. So you'll just have to write m equals negative 2 so that I know you're looking at the right number for slope. The second equation, though, you're going to have to solve for y. So everything has to divide by 4. So as you're dividing everything by 4, you'll have y equals negative 2x plus 3. So as you look here, the slope of this one is negative 2. Negative 2, negative 2. Those are the same. So the word we'll use for these lines are parallel. If we graph those two, they would be parallel lines the same distance apart. Okay, we're going to practice this again. On the first equation on the next example, 3x plus y equals 12. We're going to get y by itself, so we're going to have to subtract the 3x over to the other side. So y equals negative 3x plus 12. So the slope of this line would be negative 3. Now, as I go to solve the second equation, I can already see it's in slope-intercept form, so the slope is 1/3. They're opposite signs, and 3 and 1/3, they're reciprocals of each other. And if I wasn't sure, I could say negative 3 over 1 times 1 over 3. That gives you negative 3 over 3, which is negative 1. So if you're not sure, check their product and see if their product is negative 1. But if you can see opposite signs and reciprocals, then use your word perpendicular here. Now, if you're like me, you don't like to write that word out completely because it takes a little while. The symbol in geometry and mathematics that stands for perpendicular is that upside down T. So you can draw the upside down T, just make sure I can read it. All right, let's try this example here at the very bottom. We're going to solve for y, so we're going to need to subtract the 2x over and have negative 6y equals negative 2x minus 5. With your negatives, space them, don't lose them. Sometimes your handwriting, things get scrunched together. Now divide everything by negative 6. That's going to do some sign changes across your equation. This is going to become y equals negative 2 over negative 6 will become positive 1/3 x. And then negative 5 over negative 6, the only thing you can do is make that a positive 5 over 6. So the slope here is positive 1/3. Now, a little simpler over here, this is already in slope-intercept form, so your slope is in front of x and your slope is 1/3. They are the same. So these are parallel. All right, and I think I have one more example for you. This slope here, I have them in slope-intercept form. M is equal to 1/2 when you look at your equation there. And on this one, M is equal to positive 2. Now, the first thing I notice is they are reciprocals, but they have the same sign. They don't have opposite signs, so they are not perpendicular. They're also not parallel because 1/2 is not the same as positive 2. So, and if you're not sure about the perpendicular, 1/2 times 2 is 2 over 2, which is positive 1. That's not a product of negative 1. So it doesn't fit the definition for parallel, and it doesn't fit the definition for perpendicular. So we say that this is a neither situation.